Hello all, in this video I am going to demonstrate how the cycloidal curves are generated. Let me read the definition first. Cycloid is a curve traced by a point on the circumference of a circle which rolls along a straight line without slipping. Okay. Here the circle which rolls along the straight line, that particular circle is called generating circle, and it will be rolling over a line, right? So that particular line is called baseline or guiding line. Okay. See, for instance, if that generating circle rolls over the baseline for one complete revolution without slipping, then the distance covered for that one revolution will be nothing but the circumference of the generating circle. Okay. See, for instance, have a baseline something like this, and a generating line somewhere here. The axis of this generating circle is something like this. Okay. Let's take the center as C and the point that is on contact with the base, that is nothing but the baseline or the guiding line is capital P. Okay. So during this rotation, if you trace this point P for one complete revolution, you will get a curve. See, for instance, after one complete revolution, the circle will reach here, the circle will reach here, and the point P will reach here, and the C will be here. Okay. So after one complete revolution, the circle will reach here. Okay. The distance between these 2 points is nothing but, as I told you before, this distance is nothing but the pi d, that is nothing but the diameter of the generating circle. Okay. Let's take 2 more points in between. Okay. Or 3 more points. Let's take the center of this, center between these 2 points. So it's something like this. And if I try to draw the circle here, and let me draw the axis. Can someone say the position of P? Yeah, the position of the P will be here, and the center will be the C. Okay. And if we take one more point here in between these 2, I am going to take one more position here and one more here, and if you see, like, so here it is in the base and here it's reached the topmost point, so here it will be somewhere in between, something like this. Okay. So let's name this as P1, this is P2, and if you look at this, the P will be somewhere here, P3, and let's take this as P4. Okay. So if we connect the point P1, P2, P3, P4 sequentially, we will get the curve. So this particular curve is called the cycloidal curve. Okay. And throughout the process, the center will fall in this line. The position of the center will be somewhere in this line. This particular line is called locus of center. Okay. So I have discussed the theory of cycloid. Now I will try to simulate how the cycloid curve is generated. Okay. I am going to position my scale something like this, and let's assume this is my baseline. Okay. I am going to mark a line something like this. Okay. And over this line, and I am going to place this cello tape, and this is nothing but my generating circle. I'm going to place something like this. So in order to trace the point, I have fixed the sketch here. So when I try to rotate it, the sketch will trace the point P. So let's assume this is a point P, and the sketch will trace the point for one revolution. Okay, so I am going to keep the scale something like this, and the sellotape, the initial portion of the sellotape is something like this, and I am going to rotate for one complete revolution. So if you look at this, okay, if you look at this is the curve, the green color arc. This is the curve traced by the point P. So finally the circle will reach somewhere here. Okay, so the distance between the starting point of the curve and the ending point of the curve will be the pi d, and d will be nothing but the diameter of this generating curve. Okay, and this will be my center, and this will be my center at the end, and this line is nothing but my locus of center. This line is nothing but my locus of center. So this is how the cycloidal curve is generated. Instead of the straight line, if the particular generating circle rolls over a circle, something like on the curved path, if it rolls over the curved path, you will get a cycloid, but that particular cycloid is called epicycloid. So something like this, I have a base circle something like this, and over that I have a generating circle something like this. So if this generating circle rolls for one complete revolution over this curved path, so this curved path, this path is nothing but guiding circle or base circle. Over this base circle for one complete revolution, it will reach somewhere here. So if you measure the distance along the curved path, the distance will be pi d, and so but that is difficult to measure, right? So what we are going to do is, so we will be measuring this angle, the theta. Okay, so the theta is nothing but the distance it takes to cover the one complete revolution. So during this process, if you trace the point P, you will get a curve something like this, and this curve is called epicycloid. So instead of that, if the same generating circle rolls inside the guiding circle, so something like this, then you will get a curve something like this. That curve is nothing but hypocycloid. Okay, so these are the three types of curve that can be generated from the cycloidal family. Okay, so it has a lot of applications in the engineering field. For instance, the smaller gears, the teeth profile of the smaller gears are made of cycloidal profile, and it has some applications in watches, the dial gauges, etc. Okay, so with this basic introduction, I am closing this particular video.